Well, here we are, sitting like a mushroom cap on top of its stalk, the two cerebral hemispheres. This is perhaps the most complex and the most poorly understood collection of matter in the universe. We only observe what this part of the brain does. We are very inept at explaining how it does it. This is the area of the brain where the lights are on. This is where we perceive sensory information. This is where we initiate motor signals. This is where we have our personality, our reasoning, our judgment, our empathy, those things that make us uniquely human. Since there is a right side and a left side separated by the longitudinal fissure, we have three areas where the left and right side communicate with each other. That is the corpus callosum, and just south of the corpus callosum, which I can't point to here, there is an anterior commissure and a posterior commissure. There is nervous tissue, nerve fibers that pass from right to left and from left to right by way of those three commissural tracts, the corpus callosum, the anterior commissure, and the posterior commissure. Okay, so let's look at the external view of the cerebrum and the general areas of function that we know something about. Next slide, please. Well, without too much attention to detail here, just a general look at the cerebrum with its lobes and some of the functions that are associated with particular areas of the cerebrum. You may recall when we talked about the limbic system structures, the prefrontal cortex, situated just over the eyeballs there, listed here, the characteristic of personality, all of those other things that are uniquely human qualities are situated there just over the eyeballs in the frontal lobe. Notice there at the posterior aspect, the very last noodle of the frontal lobe, that is the motor cortex. So our function there is movement. The motor cortex is separated from the sensory cortex by what is labeled there as the central fissure. Normally that would be called the central sulcus. Also, it has been called the fissure of Rolando. I kind of like that. Anyway, separating the frontal lobe from the parietal lobe, that would be the central sulcus. So in the last noodle of the frontal lobe, that is our motor cortex. In the first noodle of the parietal lobe, that is our somasthetic or sensory cortex, which we'll take a look at in frontal section here in just a minute. So we go then from the frontal lobe to the parietal lobe. The large or the most obvious function of parietal lobe neurons is perception. We are aware, we become aware of things. People with parietal lobe lesions lose the ability to even become aware of whether they have an arm or not. Perhaps they have had an arm or a leg amputated. They are not even aware that the limb is gone. So those are things of perception. Parietal lobe functions are about perceiving the environment. That's why we have the sensory cortex there in the parietal lobe. There is a parieto-occipital fissure or sulcus, which is not shown in this picture here, but it separates parietal lobe from occipital lobe. The primary function of the occipital lobe is perception of vision and the visual association area where we make sense out of what we have seen. Over on the temporal lobe there, we have three major gyri, three big noodles, a superior temporal gyrus, which is the auditory cortex, sense of hearing. We have the middle temporal gyrus there, largely associated with memories and memory storage. And then on the bottom side, the olfactory cortex and the sense of smell. Not shown here because it is medial to the inferior temporal gyrus. Well, we would see the hippocampus and the hippocampal gyrus situated on the medial aspect of the temporal lobe. Now, if we folded the temporal lobe out of the way so that you could see deep to the entire temporal lobe, we would see another lobe of the cerebrum there called the insula. And I will have a slide concerning the insula coming up later. Okay, let's look at these things in a little more detail. Next slide, please. Well, if any of you have an interest in this sort of thing or the time to do so, there is a fine video that's available on YouTube. I watched it a couple of years ago. It is called The Lobotomist. It's an American Experience production, very educational. It's about a doctor whose name was Walter Freeman, who discovered a way to surgically intervene into the functions of the prefrontal area of the frontal lobe. So what he would do is go just above the eyeball through the wall of the orbit, and he would sever some of the connections there in the prefrontal area. Well, that's where we have our uniquely human qualities. People who had behavioral problems could be remedied by the prefrontal lobotomy. Well, after about 3,000 procedures, finally, it was decided that what Dr. Freeman was doing was quackery, but it made for a very interesting show. So you ought to watch it if you have an interest in that sort of thing. The frontal lobe is largely associated with those activities of the prefrontal area that I've already described. There is a motor association area. There is a frontal eye field where the notion to move the eyeballs would originate. Those pyramidal cells whose axons become the pyramids of the medulla oblongata. That is the motor pathway originating there in the frontal lobe. So we have our primary motor cortex there at the precentral gyrus of the frontal lobe, precentral meaning it's right in front of the central sulcus. So that's where our motor pathway originates. On the other side of the central sulcus is the parietal lobe. The very first noodle that we come to there is called the post-central gyrus of the parietal lobe, otherwise known as the somesthetic cortex. That's where we have our sense of touch. We'll look at that in a frontal section a little bit later. Moving on back, there is a division between the parietal and occipital lobes, that is the parieto-occipital fissure. Most of the functions of the occipital lobes deal with perception of visual signals, and then the large visual association area where we make sense out of what we've seen. Have a look there where the parietal, occipital, and temporal all come together. That area is called the Wernicke area. It is our language area, the ability to perceive and understand spoken and written language is a Wernicke function. Moving on to the temporal lobe, we have three big noodles there, the superior temporal gyrus, the middle temporal gyrus, and the inferior temporal gyrus. You see the three big noodles there on the temporal lobe. So the superior temporal gyrus is all about hearing. So we have our auditory cortex and our auditory association there in the superior temporal gyrus. Not labeled, but down at the bottom, the inferior temporal gyrus is our olfactory cortex, sense of smell. Now, notice where the frontal and temporal kind of come together there, the area called the motor speech area or Broca's area. So again, we're focusing on language. In this case, the ability to express what you want to say or what you want to write. If we have a Broca aphasia, then the person may very well know what they want to say, but when they try to say it, it comes out as gobbledygook. Okay, so these are just some general areas of the cerebrum and some of the functions associated therewith. If we move the temporal lobe out of the way, we will see another lobe of the brain, which is called the insula, and I will talk about that when the slide comes up. Next slide, please. Well, you know, the brain itself doesn't have any pain receptors, so the brain itself is unable to hurt. Well, in that case, all we have to do then is open up a hole in the skull and take a hot electrode and stick it to different areas of the brain. And since the person is awake and can respond, they're not under general anesthesia. They just have local anesthesia so that you can penetrate the scalp and skull. You stick the hot electrode to certain areas and they can tell you what they feel, or if it's on the motor side, that body part will move when you touch the hot electrode to it. So that enables us to map out the sensory cortex, which is the post-central gyrus of the parietal lobe, and we have mapped out the motor cortex, which is the pre-central gyrus of the frontal lobe. And so that mapping out of those things is called a homunculus. So on the left, what you're looking at is the somatosensory cortex, or the somesthetic cortex, uh, the post-central gyrus of the parietal lobe. When we touch the electron down between the hemispheres, down in the longitudinal fissure, the person will tell you, hey, don't be touching me there. That's my private parts. So you can see there that the genitalia have an area where if you stimulate that area, the person feels like something is, well, whatever, touching or itching or hurting that area of the body. So as we move up and out along the somesthetic or somatosensory cortex, notice that we go from toes to knee to hip, and then all of a sudden it shifts to the neck, head. The big thing there, notice how large the area is for the hand and fingers. Well, our hands and fingers are extremely sensitive. Notice how large the area is for the structures of the face. Well, they are very sensitive, so they have a large area of the brain dedicated to perceiving the sense of touch in those areas. So going all the way down to where the parietal lobe meets with the temporal, right there where you have gums and tongue, well, that's the last part of the parietal lobe, and that next section would be the temporal lobe. So this is the somesthetic or sense of touch area of the brain in the postcentral gyrus of the parietal lobe. On the right side, we show the motor homunculus. So this would be the pre-central gyrus of the frontal lobes, the motor cortex. So how do we learn about this? Well, we take the hot electrode and we stick it to certain areas of that part of the brain. Well, you go down in the longitudinal fissure, down there between the hemispheres. Well, the toes move. Come up a little bit more, the whole leg moves. And so it's mapped out based upon those responses that patients give when you touch an electrode to certain areas of that cortex. So notice that we have a large area given again to the fingers and thumbs, and also a large area given to the face. Well, we have extraordinary abilities with our hands. Therefore, a large area of the motor cortex is devoted to the hands and the fingers. Also, our facial expressions are a big part of our communication. The ability to move the tongue so that we can speak the ability to move the lips so that we can form words. So we have a very large area of the motor cortex dedicated to the hand and to the face. So once again, it ends right there where the parietal lobe is separated from the temporal lobe. So those are the two homunculi, the mapping out of the sensory cortex and the mapping out of the motor cortex by the use of a hot electrode on patients who are wide awake. Okay, when we take the temporal lobes and pull them down to get it out of the way, and we take the frontal lobe and we pull it up, what we discover deep to those two lobes is a fifth lobe of the cerebrum. That fifth lobe is called the insula. So what is labeled there, the frontal operculum, that just means the part of the frontal lobe that covers up the insula. Down below you have the temporal operculum, that just means the part of the temporal lobe that covers up the insula. So when you separate those two, then you expose the fifth lobe of the cerebrum, the insula. Just like the others, we have a left and a right insula. Every noodle is named, and every ditch between the noodles are named. Say, for instance, there you have the short gyrus, the central sulcus, the limen. Those are noodles and ditches between noodles that are part of the insula. Since it is located deep to the frontal lobe and parietal lobe, a lot of what it does is only now being investigated. It hasn't been known very much about what it does. So I found here where some smart guy has listed functions of the insula, and I went through these, and I'm thinking some of this appears to me to be just simply made up. Now, there are some things here which certainly are functions of the insula. For instance, monitors the gut, sense of fullness and emptiness. I think that that's probably right. Perception and integration of disgust. I think that's probably right. Primarily what we're talking about with the insula is this is where the gustatory cortex is, the sense of taste. So those things, yeah, those are well-established functions of the insula. As far as regulating the autonomic nervous system, nah, that is a hypothalamic function. Regulate appetite and eating, that is a hypothalamic function. So I'm thinking that this guy just kind of made up a few things. I would go with the sense of fullness and emptiness. The gustatory cortex, sense of taste, is located in the insula. Down below here, perception of pain. I don't think so, but whatever. The reason I think that this smart guy is perhaps not quite so smart, notice how he spelled the word awareness, awareness, and then in the next thing, social awareness. Okay, well, whatever. So a lot of these things in this list I have some questions about. And also, as far as being a funny guy, I'm not so sure that his little comic there, hey, you look fat in those jeans, and that's arising from the insulta. Well, I have a pretty good sense of humor, but I don't really find that to be too funny, Clyde. Well, it turns out that the two cerebral hemispheres are pretty much identical in their appearance, and they are largely identical in their function. But there are some differences between the two hemispheres, and these things can be discovered. It would appear that the left hemisphere, the left cerebral hemisphere, In people who are right-handed, the left cerebral hemisphere is largely categorical, which is rational, logical, mathematical. We don't want to involve any of our emotions here. It's kind of the Mr. Spock side of the brain. Uh, Generally, men are this way. Men usually think categorically. Women oftentimes think more holistically and incorporate emotional qualities into their decision making, uh, more so, say, than men. So the left cerebral hemisphere is generally regarded as that side which is rational, that side which is logical, that side which says 2 plus 2 equals 4, and there are no exceptions to the rule. So for a right-handed person, the left cerebral hemisphere is categorical. Now, as far as dominance, we talk about, well, one hemisphere is dominant over the other. In some people, there does appear to be a little bit of a, they are more left brain than they should be. The Mr. Spock type of person who doesn't give any space to things like emotions or holistic type thinking. If it isn't logical, then it isn't worth anything to those type of people. You probably know some of them. They are very nerdy. They don't have a well balanced personality because they are so analytical that they will make you sick. On the other hand, the right brain being the representational hemisphere. Notice the things that are associated with the right brain: musical ability, intuitive and nonverbal thought, recognition of faces and spatial relationships. These are things that are representational, holistic, incorporating more than one factor into the equation, unlike the left brain, which is just the facts, ma'am. I don't want to know anything else, just the facts. So there are people who are overly right brain. They may be overly uh, driven by their emotions, overly driven by their holistic approach to things, which oftentimes might result in a perfect inability to make a decision. They want to consider things for a period of years rather than, well, we need to make a decision now. So these are characteristics of the two hemispheres. Most people have a perfect balance between the two qualities. Obviously, those who are right hemisphere dominant, well, those are the artistic, those are the philosophical, those are your authors and your dreamers and your theorists. They tend to work outside the box. Those who are left brain dominant, they're pretty much trapped inside the box and nobody wants to get in the box with them. So there is just some observations. There isn't really a whole lot of science here to explain lateralization of the two hemispheres, but there does seem to be pretty good indications that, well, we have different duties on each side. Well, now that you know a little bit about the brain and some of its functions, you might enjoy watching these YouTube videos. I have provided a link to the videos. Two of them are very short. The electroconvulsive therapy and the hippocampus video are TEDx videos that contain some useful information. The documentary called The Lobotomist is the one that I mentioned to you previously. It's about 50 minutes long and it is very informative. I think that you will enjoy it. and you might even get little sister to watch it with you because she certainly would enjoy it. So if you do have time, spend some time checking out these YouTube videos.